All right. Let's get to this question. So first things first, what we realize, I think off the top of our heads, that 2 squared is equal to 4, 3 squared is equal to 9, and 4 squared is equal to 16. So what we can say is that f of x minus x squared has the roots 2, 3, and 4. So it has the form of ax minus 2, x minus 3, and x minus 4. And the reason this is the case is because it says it's degree 3. And so it's of this form. There's no extra factor. So then that means that f of x can be written as a times x minus 2 times x minus 3 times x minus 4 plus x squared. But then now let's go look at the other part of the question, which says there's lines AB, AC, and BC. So let's try to find the line equations of those as the first thing. So AB is it's between 2, 4 and 3, 9. And so the slope is obviously 5 over 1, so 5, and x. And so let's do 5 times x minus 2 and y minus 4. So y is equal to 5, x minus 6. So that's our first one. BC is from 3, 9 to 4, 16. So it's 7 times x minus 3 and then y minus 9. So y is equal to 7x. So minus 21 plus this is 12. And so that's 1. And CA, obviously from 2, 4 to 4, 16. So slope is 12 over 2, so 6, x minus 2 and y minus 4. So that's y is equal to 6x minus 8. So that's our third one. So these are our 3 lines, and they intersect. They intersect a b, or the graph at a certain point, at 3 points again, so D, E, and F. So let's plug that in. So what we're gonna say is 6x minus, or so let's start out with, so ours are, let's write the lines again, 5x minus 6, 6x minus 8, and 7x minus 12. So 5x minus 6 is equal to so then you set it equal to, okay, ax minus what is it, 2, 3, and 4, and then plus x squared. So what we know for sure, so actually what we can do is do x minus 2, x minus 3, x minus 4, and x squared minus 5x plus 6. And this is equal to x minus 2 times x minus 3. So yeah, so then what we can do is, well, in this case, neither, so we're going to have x not equal to 2 or 3 because those are points A and B, so it's something else. So we can actually cancel these out. So then you get that negative ax minus 4 is equal to 1. And then we're going to solve for x. So what we're going to do is get that x minus 4 is equal to negative 1 over a, and x is equal to 4 minus 1 over a. And in a similar process, we get that x, so 6x minus 8 is equal to ax squared, ax minus 2, minus 3, minus 4, and plus x squared. So x squared minus 6x minus plus 8 is equal to ax minus 2, minus 3, and minus 4. Well, this is just equal to x minus 2 times x minus 4. Similar concept, so this cancels. and then you get ax minus 3 is equal to 1. So then x is equal to 3 minus 1 over a. And then if you follow the same process for 7x minus 12 is equal to ax minus 2x minus 3x minus 4 plus x squared, then you get that x is equal to, what is it, 2 minus 1 over a. So then they're saying the sum of these is equal to, what is it, 24? So we have that 4 minus 1 over a plus 3 minus 1 over a plus 2 minus 1 over a is equal to 24. So negative 1 over a, or negative 3 over a is equal to, what is it, 24 minus 9 is equal to 15. And that means a is equal to negative 1 over 5. Yeah. So then let's look at what the question is asking. They're asking for what f of 0 is. So what they're asking for is, well, we already have our f, we have f of x, and all we have to do is plug in 0. So f of x is equal to negative 1/5 x minus 2 times x minus 3 times x minus 4 plus x squared. So f of 0 is equal to negative 1/5 times negative 2 times negative 3 times negative 4, and then plus 0. And then this would be 24 over 5. So we answered D. So yeah, that was basically what the problem was. And it just came down to trying to factor and cancel out things really smartly. So now let's go for a summary. We learned about various things related to quadratics, factorization, completing the square, and the quadratic formula. This is the order in which you should approach a certain way. So like first try to factor it. If it doesn't work, then try to complete the square, and worst case scenario, quadratic. Vietas formulas are very, very powerful. I brought it up so many times during the entire presentation because it's very useful. And then we have the rational root theorem, transformations and symmetric polynomials. Transformations are a simple concept, but just know how to apply them. Symmetric polynomials also, like you just need to have some useful identities on mind. For example, like x plus y plus z squared is equal to x squared plus y squared plus z squared plus 2xy plus 2yz plus 2xz. And similarly, something like, oh, x plus y cubed is equal to x cubed plus y cubed plus 3 times x plus y times xy. So things like that are very useful to know. So I would recommend also to search up any interesting identities that you may find. And then rational root theorem is obviously very useful as well when it comes to finding rational roots, as the name states. But in that process, we also apply synthetic division, which saves a lot of time than doing the entire long division thing. So so that's about it with polynomials, and thank you for your attention. If you have any questions, feel free to email me at AnanyaK at .rmc@gmail.com. Thank you.